Okay, so in this problem, we want to look at example 12 from the chapter 4-2 example handout, um, not the like homework handout. So in this problem, you're supposed to try to come up with two different equations for this graph using different trig functions. And this graph should look like either secant to you, secant x, or it should look like y equals cosecant x, but shifted around a bit. So let's take a look at one of these two. So I don't know. Let's just take a look at secant x first. So we're going to treat the parent function as y equals secant x, and then we're going to try and figure out what that turns into. So in order to do that, we need to figure out, okay, what are our vertical stretch, our vertical shift, our horizontal stretch, or shrink, right? Shrink or stretch. Let's do shrink here, shrink or stretch. And the horizontal shift. So that's what we're trying to tackle here. So if we look at this, let's figure out what secant x looks like first. So secant x, remember that's based off of cosine. It's 1 over cos. So if I graph cos kind of dotted here, secant is the one where anywhere that cosine was 0, we get asymptotes. And anywhere that it was 1 or -1, we got the same thing, and then you can form those U-shapes there. So let me read you this. So if you just drew the secant part, it goes up here, and we've got an asymptote here and an asymptote here. I'm just going to draw one period of the thing, and an asymptote here, and the main features are x equals -pi/2, x equals pi/2, x equals 3 pi over 2, and then I've got this point at 0, 1, and pi -1. Those are my points on y equals secant x. So let's figure out the stretches first, or shrinks. So vertically, normally these two u's are 2 units apart. If you look at them now, they're 10 units apart. So that means we've got to stretch it by a factor of 5 to go from 2 to 10. So it's going to be a vertical stretch, not a shrink, of 5. Shifting, whenever you want to figure out a shift, look at what happened to the zeros, right? So here, I've got this line right here, which is y equals 0. That was right in between the two U shapes, the one pointing up and the one pointing down. So if I figure out what line is right in the middle of my two U shapes right here, well, the distance between them is 10, so if I go 5 down or 5 up, then I get the line y equals, what is that, -3. So that means that the line that used to go down the middle at 0 is now down the middle at -3. So that means a shift of 3 down. Horizontal stretches and shrinks are related to period. So right here, the original period is 2 pi. Right? Whoops, I made that way too big. So here to here, that's a period of 2 pi. And remember, it's based off of cosine anyway, and cosine's got a period of 2 pi. And if we look at the new one, well, from this dot to this dot over here, that's going to be, let's see, that's 5.5. So -0.5 to 5.5 is a distance of 6. So my period in this one is 6. Let's just say the period of this one was actually something based off of pi so that we could compare it to 2 pi. So let's say the period of this was actually pi, right? Let's just suppose the period was pi. It's not, but let's just say it was. If the period was pi and the original was 2 pi and now it's pi, then it's pretty easy to see, oh, that's a shrink by a half, right, horizontally. But that's the same thing as saying, to calculate that, you would do the period that you have divided by the original period. That's the way that we get this. So the period that we have is 6. and we're dividing it by the period that we started with, which was 2 pi. So my real horizontal shrink is going to be, what is that, 3 over pi. So this is actually, and it's a shrink because 3 is smaller than pi. So it's a shrink of 3 over pi. Again, let me do that one more time here. If for some reason this period in this graph was pi, and then I know my parent function has 2 pi. To get it to a period of pi, we have to shrink by a half. So that's the same thing as taking this period and dividing it by that period. Well, it's not pi, it's 6. So it's really 2 pi, not divided by pi, but divided by 6. So it's 2 pi over 6 is my horizontal shrink, which is going to be, oh, sorry, not, other way around. I'm so sorry. It would be this period divided by that period. So it's 6 divided by 2 pi. 6 divided by 2 pi, that's 3 over pi. So it's your period divided by parent's period. Okay. And then the horizontal shift, remember, want to look at what happens to the 0. So in this case, the 0 is the y-axis, right? And notice it goes right down the middle of one of these upward-facing U's. So here's that line now. That is at -1/2. So this is the same thing as a shift of 1/2 to the left. So then at this point, I can create my new, my general points. The original point was A, secant A. And now it's going to turn into, so let's do the horizontal stuff first. So that'll be a shrink of 3 over pi. So I'm going to multiply A by 3 over pi. And then I'm going to go half a unit left. And then I've got a stretch of 5 vertically. And I'm going to go 3 units down. And then the trick for these is we call the ugly first term x, 3a over pi minus 1/2. And so if I isolate the a, I'm going to get pi, or first x plus 1/2 times pi over 3 to get the a by itself. And then I can plug that into this guy. So y equals 5 secant pi over 3 x plus 1/2, because that's my a, minus 3. So here's the secant version right there. So let me take all this stuff, see if I can shrink it down a bit. Okay, so there's everything for secant. Right? I'll just put that over here for now. So let's take a look at what happens if we did it with cosecant instead. So I'll pick a different color for this. So let's use y equals cosecant x as our parent function. So cosecant x, that one is based off of sine. So wherever sine was 0, we get an asymptote now. I'm just going to draw one period of the thing. So this would be x equals 0, x equals pi, x equals 2 pi. And then wherever sine had a value of 1, which was at pi over 2, we have the same value here. And then at -1, same deal. So these 2 points are, let's see, that's pi over 2, 1, and 3 pi over 2, -1. So now what we want to do is figure out, okay, how do I take this graph right here that I just drew of cosecant and turn it into the graph over on the right? So let's make a list of our stretches and shrinks and all that kind of stuff. So vertical stretch / shrink, vertical shift, horizontal stretch or shrink, and horizontal shift. Now, stretching and shrinking, it's not excuse me, it's not really going to change at all from what we just did with the cosecant one, or sorry, the secant one. The distance between these 2 points, the peak and the valley here, are still 2 units apart vertically. And over here, it's still 10 units apart vertically, so that was a stretch by 5. The vertical shift, well, that middle line right here at 0 is now a middle line at -3 still, so it's still a shift of 3 down. My period up here is still 6. The period of this one is still 2 pi, so I take my period and I divide it by the original period, and I get the same exact shrink that I had before. And then the horizontal shift is really the only thing that's going to be any different. Notice the 0 right here, x equals 0. That's an asymptote to the left of one of these upward-facing u's. Well, now that looks like it's here. And that is at, where is that? -2 is what it looks like to me. X equals -2. So that would mean I've shifted 2 to the left. You could argue, okay, move it to this one. That'd be 4 to the right instead. Doesn't matter either way. You'll get a different equation, but it'll still graph the same way. Okay, so that means that our original point of A, cosecant A, has now turned into, let's see, the horizontal stuff. It's 3 over pi times A minus the 2 to the left. And then stretched by 5, so 5 cosecant A, and then down 3. And so now what I can do is call this ugly x term, or this ugly term x, 3 over pi A minus 2. If I add 2 and then multiply by pi over 3, let me put the pi over 3 in front, just because that's how you usually write that stuff. So pi over 3. Sorry, I don't know why that's not showing up well. Let me write that here. Pi over 3, x plus 2 equals A. And then I can take this and write it as y equals 5 cosecant. And then now I've rewritten A as pi over 3, A plus 2. Oh, sorry, x plus 2. And then minus the 3. So here's the other way of writing it. So there are two pretty simple looking ways of writing this thing. They're both correct. You could have used different shifts horizontally, but these are the two based off, I think these are the two easiest ones to see. So, okay, I hope that helps some.